I'm about to do an installation resistance test on an entire installation. I've already set up ready for that test. I've joined my active and neutral together, the live conductors together at the mains box. I've made sure the main active is continuous through the meter position to go through to the switchboard. I've turned on the main switch and all the circuit breakers and RCDs on the switchboard, and I've also turned on all of the switches in the entire installation. So now with my meter on 500 volts range, that'll read megohms. I'll connect one of my leads to the MEN link that I've already disconnected from the neutral bar, so that side's going to the earth, and the other side of the meter I'll test to the active and neutral conductors. I'll do that by putting it onto the neutral bar. I need to get a reading here of at least 1 megohm, and unfortunately on this installation there is a fault somewhere because I've got a reading of about 0.46 megohms, which is a fail. Because this whole installation's failed the installation resistance test, I've now got to test each circuit individually, one at a time. The way that this switchboard's wired up is I've got the main active conductor coming in, feeding through the main switch, then goes through from the bottom of the main switch and feeds all the circuit breakers and RCDs. I'm going to test the first circuit on this board, this circuit breaker. At the moment, its active, which comes out of the top and feeds away to the circuit, is joined through the circuit breaker to all of the other circuit wires, which means to test that one circuit, I have to turn that circuit breaker off. That'll isolate that active from the other actives. I now want to get the neutral for that circuit, this first neutral in the neutral bar. At the moment, it's connected to all of the other neutrals. I'll have to disconnect that from the neutral bar so that I've separated that one circuit's active and neutral, separated them from the other actives and neutral, and bridge that one circuit's neutral and its active together. All the circuit switches are still in the on position because they're on from when I did the whole installation, so I'm ready to do the test. One side of the insulation resistance tester on the 500 volt range connects to the earth, and the other side of the meter is connected to that installation's active and neutral conductor. Now there's my test, that's reading infinity megohms, so that circuit is not our problem, that one is clear. The installation resistance test on the second circuit is going to be done slightly differently in that this second circuit is a 2-pole device. It's a combined circuit breaker RCD. That means when I turn off that circuit breaker RCD, that is disconnecting the active for that circuit from the other actives. It's also disconnecting the neutral for that circuit from the other neutrals. So I've got active and neutral separated from the other circuits. I want to join that one circuit's active and neutral together. So I'll put a bridge in to join those two. And now I'm ready to do the installation resistance test. One side goes to the earth, the other side goes to the active and neutral. Now that one's reading infinity megohms, so that circuit also is clear, there's no faults there. I'll repeat the process with each of the circuits. So now for my third circuit, making sure that that circuit breaker RCD is turned off. Join that circuit's active and neutral together. That's going to be one side of the test, and the other side of the test will be to the earth. And I think I found my problem. The reading here is low, the circuit fails, it is reading 0.46 megohms. Our testing procedure has found that there was an insulation resistance fault on the third circuit of this switchboard. Now I'll have to rectify that fault, retest the installation to make sure the whole installation passes, and then we can put supply on and connect up the installation.